course computer organization, and the topic is instruction formats. And let us see the concept. And so at the end of the session, the students are able to understand CPU's organization, nothing but standard processing unit organization, instruction formats, and zero. In this instruction format, there should be a different types of address instructions. So the student are able to understand with the examples: zero address instruction, one address instruction, two address instruction, and three address instruction. So let us see the concept. Instruction formats. So instruction formats. A computer will usually have a variety of instruction code formats. So we are seeing that there should be a different type, a sequence of micro operations. So like that, there will be a different variety of instruction code formats. It is the function of the control unit within the CPU to interrupt each instruction code and provide the necessary control functions needed to process the instruction. The bits of the instructions are divided into different groups called fields. So we are saying that instructions. The instruction is of different code formats, and the particular instruction is divided into some separate groups, and the groups are, we are saying that as a field. The most common fields in that particular instruction format is operation code, address field, mode field. So what do you mean by operation code? Code nothing but this code, this field stores the operation code which specifies the operation, which operations to be performed, like addition, subtraction, multiplication. And next one is address field. So that designates the memory address or a processor register. So nothing but this address field stores the particular data address, that either may be a memory address or a processor register. And the next one is mode field, which specifies the way of the operand or the effective address is determined, how the particular operand is retrieved. So this particular which is stored in the mode field. So let us go into the in-depth concept instruction format. So generally, most computer fall into one of the three types of CPU organization. So already we saw the stack organization. So like that, there will be a different types of organizations. Like majorly, there are three types of organization: single accumulator organization, general register organization, and stack organization. So based on these three types of organization, the instruction format should be different. So let us see the concepts. A single accumulator organization, these three by and using an example. Let us see an accumulator type organization. So for example, we see the accumulator is nothing but one special purpose register which is used when there is no destination register, then we are using this particular accumulator registers. For example, see this is one instruction. That instruction is add x. Add x is nothing but x is one of source, nothing but one address, which is the particular content which is stored in the x should performs the addition operation, but with whom? So this is the question mark. So by using this accumulator type organization, the contents which is stored in the X should be added with the contents accumulator. Accumulator is one special purpose register which stores the data temporarily. If we see add X is nothing but the content which is stored in the X should be added to the content of the accumulator, then it is stored in the AC accumulator. So this is nothing but a accumulator type organizations. And then next one is general register type of organization. Nothing but here there are three register address fields we are used. For example, if we consider add R1 comma R2 comma R3, nothing but these three are the different types of registers that we are used in the instruction. The content which is stored in the R2 and R3 is added, and the particular result is stored in the R1. If we see, this is an operation field which stores the which type of operation should be performed on these three registers. So this is the which type of organization is general register type of organization. So before we saw that an accumulator type organization, and this is a general register type of organization. And then last type of organization is stack organization. In this stack organization, would have push and pop instructions which require the address fields, which requires the address fields. Nothing but in previous we saw that general register type of organization and accumulator type of organization, but third one is stack organization. In the stack organization you have to remember that there are two types of operation. One is push operation and the second one is pop operation. Push is nothing but inserting an elements into a stack, and pop operation is nothing but retrieving the elements from a stack. So for example, which type of instruction we are using for implementing this particular instruction is push x. X is nothing but it is one address which stores the data. That particular data should be stored on the top of the stack. So the stack pointer is updated automatically by inserting the data. So then, to illustrate the influence of the number of address on the computer program, we will evaluate the arithmetic statement. If you see, this is an x equal to a plus b into c plus d. So this is an operation which performs the addition operation between a and b and addition operation between c and d, and both are multiplied, which is stored in the x. So this is one particular instruction we need to perform. So these different types of address instruction in this particular example. So for this, we are using the different types of different operations: add, subtraction, multiplication, and division. So there are different types of arithmetic operations. So move is used to transfer the content, and load and store for transferring to and from the memory. And AC is nothing but accumulator register. So we will assume that the operands are a memory address. For example, here A, B, C, D, these three are the memory address which stores some data, and the result is moved to must be stored in the memory at the address X. So let us see one by one exam one by one. So for example, what we are considered in the previous one is x equal to a plus b into c plus d. Nothing but the operation should be performed in a plus b, c plus d, and both should be multiplied. For example, first we have to see the three address instructions. So already we discussed the three address instruction. There should be three fields should be used in this three address instruction: source, destination, and the final result. If we see these are the three instructions which is needed to perform this particular operation. If we see, the add operation should be performed on a and b. This particular result is stored in the R1, because finally we have to multiply A and B and C plus D. So that's why we are using R1 and R2. So then add C plus D, that should be stored in addition operation. Result is stored in the R2, and multiplication x comma R1 comma R2. So R1 into R2, this particular content is stored in the m of x, nothing but which is stored in the memory address x. The result should be stored in the x. So if we see, these three are the operation and these three are the memory address which is stored to store the data. So for implementing these instruction, so we need if we need three address instruction, we need these three instructions to perform this particular operation. So let us see the to address instruction. The name itself indicates the to address instruction. Nothing but in the instruction it is restricted to use only two addresses only. But how we can perform? If we see this three address instruction, we can easily perform the operation. But how we can perform two address instruction is the instruction should be more when we are using two address instruction. Nothing but in the instruction only we can use two address only. When compared to three address and two address, the instruction should be more in the two address instruction. So that is the main difference in the three address instruction and two address instruction. So initially we have to move the data which is stored in the A into R1. So that's why we are using the special operation move R1 comma A. R1 comma A. So M of A, nothing but the data which is stored in the A will be transfer to move to R1. Then add R1 comma R2. So the data which is stored in the B should be perform addition operation or R1. So this particular register transfer notation is represented here. Then move R2 comma RC. So the final result which is stored in the uh, CE should be stored in the R2. then add R2 gamma. So likewise, these operations are needed to perform the x equal to a plus b. Then one address instruction. Under one address instruction already we have discussed that we have to use the accumulator. We have to use the accumulator. So for that reason we are using this accumulator. Only one address is stored in the particular one address is used in the instruction format of one address instruction. Load A is nothing but the data which is stored in the A should be transferred to the accumulator. After that add B, nothing but the data which is in the B should be added to the AC, and the result is like stored in the AC. So like that, for performing this particular operation, we use these instructions to perform this particular operation. Then zero address instruction is nothing but we can use only nothing but we cannot use nothing but the address. We can, because here we are every operation should be every retrieval deletion should be done by using the top of the stack. So that for that we are not assigning, we are not giving any address in the instruction. So a push a is nothing but the content which is stored in the a should be top of the stack. Then push is nothing but inserting. So inserting is nothing but inserting an elements into a stack. So after pushing A, then pushing B. After that, we have to perform the addition operation between A and B, so that we have to give add. So which we are giving add. What happens is the top of the stack both should be added automatically. If the added, then push the particular C, the result of A plus B into a C. So then we have to give C. So likewise, we have to perform this particular operation by using the zero address instruction. So by the end, we have to go for a glossary, and the push is nothing but it is a stack operation, nothing but is inserting data into the stack. Pop operation, it is a stack operation, delete data from the stack. The next topic is addressing modes, and sample short answers is what is one address instruction with one example. What is a zero address, what is a three address instruction, what are the different types of organization. So likewise, this should be a sample, there should be a short answers question, or either maybe a sample longer questions like explain briefly about instruction format with an example, or either maybe explain briefly about one address, zero address, two address, three address with an example. So like this, you should be asked like a long answers question.